Let's take a look at Unit 6, quadratic functions. Now, first learning objective is solving quadratic equations. Quadratic means the highest power, it's polynomial of course, but the highest power is 2, so x squared. You don't have an x to the third or x to the fourth or anything higher. And get to my tablet. There we go. First thing we're going to talk about is something called the square root property. That's one method of solving a quadratic. Let's take a look at this example right here. X squared is equal to 9. Now what the property states is if you got something squared equal to something else. That means this entire left side has to be squared. In this case it is. I just got a single x over here. Nothing in front of it, nothing after it, just the entire left side squared. If that's true, then you drop your squared and you put a plus or minus square root on the other side. So for this example, I would drop my squared and I'd put a plus or minus square root around the other side. Now square root of 9 gives you 3, so your answer would be a negative 3 and a positive 3. Those would be your two answers. Now if you had something look like this, 2x squared is equal to 8. Now again, the entire left side has to be squared in order to use this property. So the squared here only applies to the x, does not apply to the 2. So we have to get the part that's squared by itself. So we'd have to divide both sides by 2 to begin with. Did that, those 2's would cancel. And 8 divided by 2 is 4. Now the entire left side squared, so we'll drop our squared. And you put a plus or minus square root around the other side. And square root of 4 is 2. So our answers are negative 2 and positive 2. Now it doesn't have to be a single variable. It can be anything squared. For example, if I had 3x minus 1 squared is equal to 7. Well, the entire left side is squared. That's all this property states. So it says we drop our squared and we put a plus or minus square root around the other side. Now to get this one completely solved, we have to take the negative 1 over. That's like adding 1 to both sides. And then we have to divide both sides by 3. We get 1 plus or minus square root of 7 over 3. And that would be our answer. Now, what's even more specific about this is this has to be a number on this side. If you have a variable over here, this does not work. So, got to have a number on the right side. Now I'm going to show completing the square, just in case there's any problems dealing with it. The YouTube videos that I have out there will go into it and give you all the steps and everything, but I just want to show you one example. X squared plus 6x plus 1. Let me think about this. B squared minus 4ac. Okay, that'll work. Now our first step in completing a square is you divide divide everything, both sides, by the number that's in front of your x squared. There's no number for our x squared. Step 2 is we take our number over to the right side. That's the constant term. So take the positive 1 over the right side, becomes a negative 1. Step 3, you take whatever number's in front of your x. That's called coefficient. which in this case is a positive 6. Sign would be included. If this was a negative here, we'd have a negative 6. You multiply it times a half and you square it. It's always times a half and it's always squared. 6 times a half is 3, and 3 squared is 9. And then we add that to both sides. So we're going to have x squared plus 6x plus 9 equals negative 1 plus 9. Notice I put parentheses around the 3. That's kind of important. I shouldn't have dropped that. Now we want to factor the left side. This factors as x plus 3 squared. Negative 1 plus 9 is 8. I don't know what factors like that. Whatever number is right here, right before you square it, sign included. In this case, there's a positive there. So whatever number is right here, sign included is always what goes right here. Now we can use the square root property. So the square root property says you drop your squared, and you put a plus or minus square root around the other side. Now take the 3 over, becomes a negative 3. And 8, if I did the prime factorization, is 2 times 2 times 2. Remember with square roots, we're looking for pairs of something. Here's a pair of 2, so a pair of 2 is going to come out in front as a single 2. And we get x equal to negative 3 plus or minus 2 square root of 2. Now I'm showing you an easy example here. You might look at this and think, well, that's not horrible. It's not the easiest problem, but it's not horrible. This is easiest type because there's an even number for your x. If I had put an odd number here, it would become kind of hideous. There's an easier way to solve these if you can't actually factor it. But first we'll look at factoring, even though we've seen that before. This is the zero factor property. And let's say we have x squared minus 5x plus 6 equal to 0. If, we obviously can't use square root property because I get the squared by itself here, but I have to take these over to the right side and I'd have an x over here. But this factors using the PST method. So this factors as x minus 2 times x minus 3 equals 0. Now, zero factor property says you get 0 on one side, you factor the other side, you set each factor equal to 0. So I'd set x minus 2 equal to 0, and I set x minus 3 equal to 0. Take negative 2 over, becomes a positive 2. Take negative 3 over, and becomes a positive 3. So those would be our two answers. Now we have something called a quadratic formula. If you have something that doesn't factor, you typically never use completing the square. You use quadratic formula. This is specifically meant for solving quadratics. And you're going to have it in the form of ax squared plus bx plus c equals 0. So you have your x squared, your x, no x, and you have 0 on this side. The a, b, and c represent numbers. If you have in that form, then you can write your answer down directly using x equals negative b plus or minus square root of b squared minus 4ac all over 2a. I don't remember the problem I had earlier, but this is probably close. X squared plus 6x plus 1 equal to 0. And we use completing the square, whatever the form was. I'm not remember if there's a 1 there or not, but we're going to use for the quadratic formula now. So we'll identify our a first. A is whatever number is in front of your x squared, which is 1. B is whatever number is in front of your x, which is 6. And C is your number at the end, which is 1. Now, I would include signs. If this was negative, this would be a negative 6. Then we go through, and everywhere you have a variable, you go through and replace it with a set of parentheses. Everything else remains exactly as is. So replace the A, B, and C all with those parentheses. Now B we said was 6, so everywhere I had a B I'll put in a 6. A we said was 1, so everywhere I have an A I'll put in 1. And C is 1, so everywhere I have a C I'll put in a 1. And then you simplify. So we got negative 6 plus or minus square root. 6 squared is 36 minus 4 times 1 is 4 over 2. Which gives us negative 6 plus or minus square root of 32 over 2. Always want to simplify your radicals if you can. So we got negative 6 plus or minus 36 is 2, 4, 8, 16, 32, 5 2's. Remember, we're looking for a pair of somethings. Here's a pair of 2's, so that's going to come out in front as a single 2. Here's another pair of 2's. That's going to come out in front as a single 2. So we got x is equal to negative 6 plus or minus 2 times 2, square root of 2. We're left with a single 2 inside. When you bring those items out in front of the radical, remember they have multiplication in between them. So we got x equals negative 6 plus or minus 4 square root of 2 over 2. Now, normally, that would be our answer. But there is one specific case where you go further, and this happens to actually be that case. Is if you can divide this number, and this number by the same number, do so. And they're all divisible by 2. That gives us negative 3 plus or minus 2 square root of 2 over 1. Or x equals negative 3 plus or minus 2 square root of 2. And that's our answer. Clear that off. You might be looking at this and think, well, that's just as many steps as completing a square. In some cases, it may seem that way. But you're going to find that when you got one of the harder types, it actually saves you work. Okay. Now this next one talks about adding, subtracting, multiply, divide, and simplify complex numbers, and solve quadratic equations with complex number solutions. So let's talk about that. We have complex numbers, which is actually contains the real numbers also. But our standard form looks like this. We got a plus bi. A and b are numbers. Example, 3 plus 5i. That'd be a complex number. Although, like I said, the complex numbers actually include the real numbers too, so if I just had 7, that'd be a complex number. You might say, well, why? It doesn't have an I. Well, I could put an I there. 7 plus 0i, and that'd be in the standard form. We don't actually put the 0 there, the 0i. We just write 7. But that's why the real numbers fall underneath complex numbers. Well, question is then, what is an I? That's the imaginary part. And it comes from the definition when you got a square root of a negative 1. That gives you an I. It's actually a little bit more than that. Whenever you have an even number as your index, it gives you an I. Because from what we've seen with radicals before, we can't simplify this because there's nothing times itself gives you a negative 1. You might say, well, what about negative 1? Well, negative 1 times negative 1 is a positive 1. So that's our definition of what an I is. In some cases, you may have to simplify a radical and get an I. Like here, we got negative 1 times 48 is 2, 4, 8, 16 times 3. So if we did the prime factorization, it gives us that. This pair of 2's is going to come out in front as a single 2. This pair of 2's come out in front as a single 2. This negative 1 will come out as an I. So we're going to have 2 times I, and we're left with a 3 inside. So that gives us 4I square root of 3. In some problems, you will have to simplify the radicals before you combine them together, if there is any of that type. Now, once you have them in standard form, there's different operations you can do. Let's say I have 3 plus 2i plus 5 minus 7i. This is addition. Always the same way, you want to get rid of your parentheses. In this case, these parentheses aren't doing anything, so I just drop them. The thing about i's is you treat them just like a variable. So we combine our numbers together. So we got 3 plus 5 gives us 8. And then we combine our i's together. Because again, if that was 2x and this was a negative 7x, we'd know how to combine it. And the same principle holds true here. Since these are both i's, I'll add or subtract the numbers in front. 2 and a negative 7 gives us negative 5i. And that's our answer. So again, just treat them like a variable. We get to multiplication and division, we have to do a little bit different. Let's say I got 7 plus I minus 3 minus 4i. This is subtraction. Well, still again, same principle. You want to get rid of your parentheses. This first set of parentheses doesn't do anything, so I can drop it. So I got 7 plus I. Here we got a minus, a negative out in front of our parentheses, so this is going to flip the sign of everything inside. So the positive 3 becomes a negative 3. The negative 4i becomes a positive 4i. Then combine our numbers together. 7 minus 3 is 4. And combine our i's. We got I plus 4i. Well, this I here has an invisible 1 in front of it, so that's 1i plus 4i gives us 5i. And that'd be our answer. Now for multiplication. There's one important note to keep in mind, and we'll talk about why this occurs here in a little bit. But you run across problems where you have an I squared. And standard form says you can't have an I squared. Well, recall, this shows where it comes from, we said earlier that a square root of negative 1 is equal to I. Well, think about what happened if you'd square both sides. Remember, when your index matches the power, they cancel each other away, so that gives us a negative 1 over here, and then that's just I squared. So I squared is actually equal to negative 1. You'll use that note in multiplication and division problems. For example, if I have 4 plus 3i times 2 minus I, we want to multiply these together. Remember I said you treat them just like variables, which you still do. Remember the FOIL technique? First, outer, inner, and last. So we'll multiply the first items together. So we'll take 4 times 2. We'll multiply the outer items together. 4 times negative I. We'll multiply the inner items together. 3i times 2. And we'll multiply the last items together. 3i times negative I. Now 4 times 2 is 8. 4 times negative I is negative 4i. 3i times 2 is 6i. 3i times negative I is negative 3i squared. Okay. You always want to combine together numbers, combine together i's, and so forth. So we got negative 4i plus 6i, that gives me 2i. Minus 3, and here we have an I squared. We can't have an I squared for standard form. But up here we said I squared is equal to negative 1. So we'll replace the I squared with negative 1. Negative 3 just carried down out in front. So we've got 8 plus 2i. Negative 3 times negative 1 is a positive 3. 8 plus 3 is 11 plus 2i. And that would be our answer. Now division is a little bit different. It still uses this principle here of I squared is equal to negative 1. Division really isn't division as you might think of it. And we've got two types. We got one type where we got a single item down here. 3 over I, for example. It might be 5 over 2i. We have a single item down here. Versus two items, where you have a plus or minus between them. Whenever you have a single item down here and has an I, your technique you want to do is you want to multiply the top and bottom by I. You might say, well, where's the division at? Well, it's not quite division like you think. We just can't have an I in denominator. 3 times I is 3i, and down below, I times I is I squared. You might say it's worse now. We have two i's down there. But remember from our definition, I squared is equal to negative 1. So then 3i divided by negative 1 gives us negative 3i. And that would be our answer. Let me grab a drink here. Then we'll look at a case where we have two items down there, one of which is an I. Okay, let's say we got 5 over 2 plus I. Notice that we have two items down here. Two items, that's where you have a plus or minus between them. And at least one has an I. How you handle that is you multiply the top and bottom by the conjugate of the bottom. What's conjugate? Conjugate is where the first is the same and the last is the same. So this is 2, so this is 2. This is I, so this is I. But the sign in the middle is different. This is a plus, so this will be a minus. And whatever you multiply by the bottom, you multiply by the top. If I had, let me show you another. 3 plus 8i down here. I'd multiply top and bottom by 3 minus 8i. That's a conjugate. First is the same, last is the same, sign in the middle is different. Okay. Now here, I'll multiply 5 times 2 and 5 times negative I. That gives us 10 minus 5i. The nice part about conjugates is all you have to do is multiply the first parts together and last parts. So we'll take 2 times 2, and we'll take I times negative I. So you don't have to fully FOIL it. You just have to multiply your first items and your last items. So we got 10 minus 5i. 2 times 2 is 4. I times negative I is negative I squared. Four minus and I squared, remember, is negative 1. So replace just the I squared with negative 1. So it gives us 10 minus 5i. Here's a negative negative. It gives us positive. 10 minus 5i over 5. Now you have to remember, assuming it doesn't disappear, that standard form says the real part should be separate from the imaginary part. So at this point, you'd always take your real part, which is 10, put it over your denominator, minus your imaginary part, 5 over 5 with an I to the side. So again, I split these into two separate fractions. In this case, it simplifies. 10/5 is 2 minus I, and that would be your answer. Now, these are used in everyday work by electrical engineers. So they actually do have a practical purpose. Where you would see them in algebra is when you're solving a quadratic equation. I'm going to make up one. Let's see. X squared plus x So b squared minus 4 times a times c. So plus 10. Okay. I'm going to use the quadratic formula to solve this. So identify a, which is whatever number's in front of our x squared. We identify b, which is whatever number's in front of our x. And our c is our constant term, this number over here, which is 10. Remember, our quadratic formula is x equals negative b plus or minus square root of b squared minus 4ac all over 2a. So we're going to have negative, we'll put a 1 in for the b, plus or minus b squared. So I got 1 squared minus 4 times a, which is 1, times c, which is 10, all over 2 times a, so 2 times 1. So I got negative 1 plus or minus square root, and I got 1 squared, which is 1, minus 4 times 1 times 10 is 40, all over 2, which gives us x equals negative 1 plus or minus square root of negative 39 over 2. Now remember, we always simplify our radicals. 39 I can't do anything with. 39 is 3 times 13. But the negative inside comes as an I. So I got negative 1 plus or minus I square root of 39 over 2. And since we have an I, we want to split the real part separate from the imaginary part. So I'll put negative 1 over 2 plus or minus square root of 39 over 2 with an I to the side. And that would be our answer. So this is where one case where you see it in algebra, where you end up with a negative inside of your square root. Now our last topic is graphing quadratic equations in two variables. Example, if I had an quadratic equations. If I had an x squared minus 5x plus 6. Now typically this is written in function format. So if you had f of x is equal to x squared minus 5x plus 6. Or it might be y equals. You see how it says graphing quadratic equations in two variables? You may have this form or, like I said, this form. Both of them represent two variables, because remember the f of x and y are interchangeable. Now there's different items we can find that'll help us with this. One of them is to find the vertex. The vertex formula officially looks like this. Negative b over 2a, f of negative b over 2a. Now this is in function notation. So that's why I wanted to introduce both of these, because this one has f of. Now first step in using the vertex formula is to identify a and b. Now a is whatever number's in front of your x squared. So in this example, the number's in front of your x squared is 1. B is whatever number's in front of your x, which in this case is a negative 5. Then we want to plug a and b into negative b over 2a and simplify. I'll continue up here. So negative b, which is negative 5, over 2 times a, that gives us 5 halves. Or if I put that in decimal form, that'd be 2.5. Decimal form is actually a little bit more beneficial when we're graphing. The 5/2 is what we'll use in the next step. Step 3, plug the value from step 2 into the original function and simplify. So it doesn't matter which one you go to, but we'll just go the right side because that's really all we need. X squared minus 5x plus 6. Now if I put 5/2 in there, I got 5/2 squared minus 5 times 5/2 plus 6. Gives us 25/4 minus 25/2 plus 6. Get a common denominator of 4. Here I'd multiply top and bottom by 2 to get a common denominator, so that's 50 over 4. And 6 is 24 over 4. So it gives us, let's see, 25, 49, negative 1/4. Or negative 0.25. Now our vertex is 2.5, negative 0.25. .5. 1, 2, 3. So 2.5 and negative 0.25, maybe right there, roughly. Now another thing we find is we find the x-intercepts. We have y is equal to x squared minus 5x plus 6. Yeah. So to find the x-intercept, you always plug 0 in for the other variable. So I plug 0 in for y. Now here this will factor x minus 2, x minus 3. You might have a different problem where you have to use quadratic formula. And if I set zero factor property, I set each of these factors equal to 0. I got x minus 2 equal to 0 and x minus 3 equal to 0. What gives us x equals 2 and x equals 3. It should be right there and right there. Then, since I know they're kind of a U-shape, I could go ahead and kind of estimate it now. If you want a little bit more precision, you could find a y-intercept. Y-intercept, you plug 0 in for x. So I'd have y is equal to 0 squared minus 5 times 0 plus 6, or y is equal to 6. Which means I'd put a point at 6. And so I know they're a U-shape graph. So I could then finish my sketch, and that'd give me that graph. Now, sometimes the x-intercept, y-intercept's always easy to find. Sometimes the x-intercept's a little bit challenging to find because you'd have to use a quadratic formula. And you may find it easier to just plug in points. Like instead of trying to find the x-intercepts, maybe you'd plug in x equals 1, x equals 2, x equals 3, x equals 4, and then just see what it gives you. So that'd be the alternative way to do it. And that's the last of the material for the course.